Hey guys, we've got a derivatives question today, or a calculus question today. So it's asking us to find the equation of the line tangent to the function at a given point. Your answer should be in slope-intercept form. Okay, so just for a bit of a refresher, slope-intercept form is in this form here. We've got y equaling mx plus c. Cool. So in this video, I'm going to assume that you know how to calculate a derivative, and we're just going to work through the process of getting a line tangent to the function at a given point. So what we're going to have to do is we're going to try and figure out first what we're actually trying to do. So if we've got, I'm just going to draw a random function here. So if I just have some kind of cubic function. Now, what we're looking for is if we've been given a point, let's say on the function here, the tangent is the line that goes and cuts the point, or that cuts the graph at the point that we're given. So in this one it's 2, 2, and in this one it's 1, 1. So we're looking to find the equation of this line here, the black one. So what we're going to have to do is, to start with, we're going to find the gradient of the line at this given point. And basically the way we'll do that is we're going to compute. So if we're given this point, like let's just say we're given a point A, comma B, the first thing we're going to do is we're going to calculate the derivative, and we're going to evaluate it at the point A. And what that's going to be in this function, that's going to give us our m value. Now all we'll be left to do after that is we're going to have to find c. Now what we can do then is, if we have our m value, we can put in the point, like in this case it's 2, 2, we can substitute that into our linear graph, and we're going to have 2 equals whatever the gradient becomes times 2 plus c, and we can solve for c. So this is basically, apart from the actual method used to differentiate these questions, the actual underlying couple of steps are exactly the same every time. So let's get to it. So in this one here, we've got y is equal to x cubed minus 2x squared plus 2. So I like to use this f of x notation. So we're going to write f prime of x is going to be equal to, we've got 3x squared minus 4x. So what we then do is we're going to evaluate this at x equals 2. So we're going to go f prime at 2. And that's going to give us 2 squared is 4 times 3 is 12 minus 4 times 2 is 8, which is equal to 12 minus 8 is 4. So we can then say that m in this equation is going to be equal to 4. Alright, so we're off to a flying start. The next step, like we said, is we have to substitute that into our gradient intercept form, which is equal to 4x plus c. And then we substitute in the point 2, 2. So we know that 2 is equal to 4 times 2 plus c. So here we have, then we just solve for c. So we have 8 here, 2 here. So c is going to have to be minus 6. So when this comes out, we've got our m is equal to 4. We have our y-intercept of 6, and we get our graph, or our tangent function for x take 6. Cool. Now, let's just separate these out. Use a different color. All right. So here, this one here is a little bit more tricky, but essentially we're going to do the same thing. The only thing that's going to change is the method by which we use to differentiate it. Now, we've got our x values that we're trying to differentiate with respect to in the denominator here. Now, that makes it a lot more tricky. So what I'm going to do is I'm going to rewrite this function with the x squared minus 4 in the numerator. So I'm going to write this as the function of x is equal to -3 bracket x squared take 4 to the -1. So that's how we could bring that entire thing up. We'll put it in brackets and put it to the power of -1. Now, if we go take the derivative of this, we have to use the chain rule. So this is going to equal -1 times -3 is 3. We leave the inside function as it is. We drop the power by 1, and then we multiply it all by the derivative of the inside function. Simplifying, this will give us 2x times 3 is 6x, all divided by and that's our derivative there. Cool. So then what we're going to have to do is we're going to have to find m, we have to evaluate our derivative at x equals 1. And that's 6 times 1, which is 6. 1 minus 4 is -3, all squared is 9, which is equal to 2/3. Again, like we did over here, we substitute this into our gradient intercept equation. Y equals 2x on 3 plus c. We substitute in our 2 points. And we're left with 1 equals 2/3 plus c. And it's quite simple to see that c is going to have to equal 1/3. So our equation then becomes y equals 2x plus 1 all divided by 3. Okay, so you can see that when we work these out, there is a definite method. We calculate the derivative, we evaluate it when x is equal to 1 to find our gradient of the tangent line, and then what we do is we use that to substitute into the gradient intercept form of the equation, this y equals mx plus c. And then we use both the fact that the tangent will also have to travel through 1, 1 to solve for c in our gradient intercept form. It's not too tricky, you just have to make sure you know all the different ways that you can differentiate functions, and essentially the final part of the questions are always exactly the same. So I hope that video helped. If it did, give it a like, subscribe to my channel. I try and put out new videos every day, but you can never get them out every day. And I'll see you again next time.